This video will cover some of the derivative rules which form part and a crucial part of the AP syllabus. Before we start, it's best to familiarize ourselves with these three rules which form the main part in derivatives with AP maths. So the product rule is obviously when you have two terms next to each other, each with a coefficient. Then what we need to do is we derive the first term multiplied by the second term plus by the derivative of the second term multiplied by the first term. Then we look at the quotient rule. This is when we have one term over the other, both with x's or coefficient. So first things first, derivative of the top multiplied by the bottom minus by the derivative of the bottom multiplied by the top over the bottom squared. Don't forget that bottom squared. A lot of students forget it. Then the chain rule is probably the simplest of them both. It's when you're given a bracket with a power, derivative of the bracket multiplied by the derivative of the inside of the bracket. If that all sounds a bit weird to you right now, we will go through some examples just now which will illustrate these rules practically. Just a side note, what they often do is they incorporate this chain rule into the quotient and product rules in some of the harder examples, and they're most likely the examples that you'll find in a test or exam. So we'll just go through some examples just to illustrate some of the rules. And please note that these examples also focus on E, which is another part of the AP syllabus. So we just try to combine deriving and E into one section. The first sum says f of x equals 2e to the x plus by e to the minus 3x. So we obviously write the sum out. Then what we do for the derivative of e is we literally, so you see there's a plus sign, so you're obviously working with two separate things. There's no multiplying sign, so there's no need for the product rule. So all you're doing with e is you're repeating what is said in the question. So 2 to the ex, which is said in the question, you're repeating that, but now you're multiplying it by the derivative of the exponent. So the derivative of x is obviously 1. So it's 2e to the x multiplied by 1. Plus by, you write out exactly what's given, e to the minus 3x multiplied by the derivative of the exponent. The derivative of minus 3x is obviously minus 3. Then we simplify that and we get 2e to the x minus 3e to the minus 3x. The second example, f of x equals x squared multiplied by e to the minus x. Immediately before even looking at anything, you can see two terms being multiplied together, both with x's. You've got to be thinking product rule. So we come down to our working out for the second sum, which is here. We write it out. Product rule obviously says derivative of the first, which is x squared. Derivative of that is 2x, because you hop that down. Multiplied by the second, you obviously leave the second as it is, plus by the derivative of the second. Remember, derivative of e, you write it out, multiplied by the derivative of the exponent, minus x, which would be minus 1, multiplied by the first term. Simplify that all out and you'll get an answer like that. Then we look at the third example, f of x equals e to the 2x over x. You've got to be thinking, I've got two terms, one over the other, both with x's. Immediately think quotient rule. And sure enough, here we have it. You write out your sum. Your derivative obviously says derive the top term, so e to the 2x, you write it out, multiplied by the derivative of the exponent, which is obviously 2, multiplied by the bottom term, which stays unchanged, minus, and now note the minus is different from the product rule. The product rule is a plus, minus the derivative of the bottom term, derivative of x, which is 1, multiplied by the top term as it is. Don't forget, over the bottom squared. So the bottom here being x, so we just square it. Then all you can do is you just simplify it out and you will get your answer to be that. Then if we look at the fourth and final example for this particular set of examples, f of x equals to 1 over the square root of 2e to the minus x plus 1. So now you might be thinking fraction, let's just do the quotient rule. However, you can't derive 1, so you've got to be thinking something else, and sure enough, it's the chain rule. Now importantly, for the chain rule, you need to have, or you can't have a fraction for the chain rule, so that means that if we look at the answers for the example, you've got to flip that up to the top by making it a negative exponent. Then all you're doing for the chain rule is you hop the exponent down, like I've done there, minus a half, leave the bracket as it is, then minus a half minus 1, which comes out to minus 3 over 2, multiplied by the derivative of what's inside the bracket. What can we derive here? We leave obviously 2e to the minus x, then we multiply it by the exponent, the derivative of the exponent, which is minus 1. Then we can just simplify that all out and we should get an answer like that. Then a bit more application type questions, which will certainly come up. Find the equation of the tangent to the curve of f of x equals e to the 2x minus 3x at the y-intercept. So at the y-intercept, you obviously know that x is equal to 0. First things first, you always find the derivative of the sum they get you. Even if you cannot find the total answer, you will get some marks for just finding the derivative, and this derivative is easy. You obviously leave the e to the 2x as it is, multiplied by the derivative of the exponent, which happens to be 2, minus by the derivative of 3x, of minus 3x, which is minus 3. Then as I said, at the y-intercept, you know at the y-intercept x is equal to 0. So then what you do is you find out the gradient of the curve at x equals 0, and obviously gradient is the derivative. So you find your derivative and you sub in 0 and you find your gradient to be minus 1. So now you know that your gradient at the y-intercept, or at x equals 0, which is the same thing, is minus 1, and you know that a tangent will have the same gradient at that point. Then what you do is you obviously now need to find a point so that you can use your y equals mx plus c, or y minus y1 equals to mx x minus x1. So what you do is you obviously take the x equals 0, you sub it back into the original equation, and you get a y value for that, and you should get 0 and 1 respectively. Then all you're doing is y equals minus x plus c. You know your y-intercept's 1, so it's y equals minus x plus 1. Then if we just look at a couple more examples, find f dash x, e to the power of square root x. All we got to do for this is obviously write it out as it is, multiplied by the derivative of the exponent. Now remember, when we're working with derivatives of exponents, we always turn them into fractions, which would be x to the 1 over 2. Now we apply the chain rule. We jump the 1 over 2 down, multiplied by what's in the bracket, minus by 1 over 2. Then you obviously take 1 over 2 minus 1, which becomes minus 1 over 2, multiplied by an invisible 1, because that's the derivative of what's in the bracket, but it doesn't change it, so we have left it out. Then the derivative of e to the 1 over x, all we're doing here is, it's very simple. We're taking the derivative of e to the 1 over x, leave that the same, multiplied by the derivative of the exponent. Obviously flip the x up into minus 1, jump the minus 1 down, which gets us that minus, then minus 1 gives us the minus 2. Then if we look at example 3, e to the power of the square root of 1 minus x squared. Obviously this exponent must be written like this. So you leave it the same, multiplied by using the chain rule, you jump the half down, leave the bracket, then you obviously say a half minus 1, 1 over 2, multiplied by what's inside the bracket, or the derivative of what's inside the bracket, which is minus 2x. Simplify that and you'll get something like that. Then if we go to the fourth example, that's our fourth example. Derivative of that's easy, leave it the same, multiply it by the derivative of the exponent, which is just plain deriving. Fifth example, there's a normal plain straight derivative here, which is obviously jump the 2 down, you get 4x plus by, leave it the same, multiplied by the derivative of the exponent. Here is a little chain rule. You're obviously hopping the 4 down, so you're getting minus 4. 4 minus 1 leaves you with 3. And just two more exponents, or two more application type questions rather. Find the equation of the tangent to the function for these examples. Y equals 2x minus e to the power of minus x at x equals 0. So what we do is we obviously find the derivative, and I've gone through a lot of examples now about how to find these derivatives, and you'll get something, you'll get this. Then what you obviously do, you're given a point, so you must plug in x equals 0 back into your original equation. Just remember, back into your original equation, not the derived equation, and you'll get your y point to be 1. Then all you do is you find the gradient at the point you asked for, so add x equals 0, which happens to be 3. Then you use your other point and you'll get y equals 3x plus 1. Then if we look at b, find the equation of the tangent to the function y equals e to the minus 2x at x equals ln 2. Then, so obviously we write it out, and then we get our x point is obviously ln 2. Then what we have to do, we obviously trying to find a y point to use. We sub that back into the original and we get 1 over 4. Then we find the derivative of our equation, e to the minus 2x multiplied by the derivative of the exponent, which is minus 2. And then what we get is that. Then we obviously sub in ln 2 to find the gradient at ln 2, and that happens to be minus 1 over 2. Then we use these 2 points, simple maths, and we get y equals minus 1 over 2x plus by 0.59. That concludes the video on derivatives for the AP section, specifically focusing on E. The next video will be on derivatives of ln, which is another story, which is another section of work. Thank you very much.